So Unit 6, Day 3, we're going to talk about side, 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 and side, angle, side similarity. So we talked about angle, angle similarity yesterday. So that said that if we can show that two angles in one triangle are congruent to two angles in another triangle, then those two triangles are similar by angle, angle similarity, right? And so we found missing angles by triangle sum theorem, add them together, subtract 180, and all that good stuff, right? And if we could show, and we could use vertical angles. Sometimes we had parallel lines. We could use alternate interior angles. So if we could show those angles were congruent, that two pairs of angles were congruent, we could say that they were similar by angle, angle. All right. So today we're going to do it by side, side, side similarity to start with. And we know that in similar triangles, the sides are what to each other? Proportional. Okay? So the side theorem basically says that if I can prove that all pairs of sides are proportional, then the triangles are similar. So that means all three pairs of sides with their corresponding sides in the other triangle are going to be equal ratios. They're going to simplify to the same ratio. Okay? So look at number 1 here. I have drawn 3 triangles. Okay? I have drawn 3 triangles, and I even color coded. I didn't have to, but I color coded. Red, green, and blue. So is either triangle DEF, which is this little one out here, or triangle GHJ similar to triangle ABC? So here's triangle ABC on the far left. Its segments are marked, and they're color coded because why not? And I want to see if they are similar. Well, the side postulate says that they don't have any angles congruent. So I'm not going to use anything with angles, so we know it's side if it's true. We're going to see if any of the corresponding sides are proportional. That means they're all equal ratios. So I actually color-coded them, but they don't have to be color-coded, okay? Because if I'm comparing these two triangles right here, which is what I'm going to do first, what's the smallest length in this ABC triangle? 8. What's the smallest length in the DEF triangle? 6. So you would put smallest with smallest, right? Middle with middle and largest with largest. That makes sense? So if it's not all nice and pretty and color-coded like I did, okay, you do smallest with smallest, middle with middle, largest with largest. Does that make sense? Okay. So the smallest one is 8. So 8 over 6. What does that reduce to? 4 over 3. So if all of the other ratios from A, B, C to D, E, F reduces to 4 over 3, then they're similar. Okay? If all the other fractions reduce to 4 over 3, then those would be similar triangles. Does that make sense? Okay, so the middle one, the middle lengths are 12 for ABC. What's the middle length for DEF? 9. What does 12 over 9 reduce to? 4 over 3. So far, so good. What's the longest side in ABC? 16. And the longest side in DEF is 12. What does 16 over 12 reduce to? 4 over 3. So all of these had equal ratios, right? They're proportional. They all reduce down to 4 over 3 for the scale factor. Y'all see that? So ABC with DEF, yes, they are similar. By side. Corresponding sides reduce down to the same ratio for all 3 sets of sides. Do y'all see that? Oh, I'm sorry. All right, so let's try ABC now with the last triangle, GHJ. Okay, so what's the shortest side in ABC? 8. What's the shortest side with GHJ? 8. What does 8 over 8 reduce to? 1.
What's the middle side in ABC? 12. What's the middle side with GHJ? 10. What is 12 over 10 reduced to? Or 10, sorry, yeah, 12 over 10. It's 6 over 5, isn't it? Are those equal ratios? No, so these would be not similar. So if they reduce down to the same ratio, they're similar. If they are not reducing down to the same ratio, they're not similar. So do y'all see how to check that? Okay, so you do all corresponding sides. Okay. Number 2. Draw this picture, please.
Now, if we're breaking down 30 is factors of 3 it's only perfect square factor is 1. So we can't break that down anymore and get any more perfect squares other than this. So I can 2 perfect squares of 4 and 4. Alright? What's 4 squares? 15. So in this case, 16 multiplied by 30 is equal to 8.
Okay, they did give me a similarity statement right here, so that is helpful. All right, so if they give you a similarity statement, that is helpful because that lets you know what segments are supposed to go together. So, do I have a pair of segments where I know both the measures exactly without variables? Which one? Yeah, A, B, and D, E, right? I know both of those are 4 and 12. Okay, so if it says find the value of x that makes these triangles similar to each other, that just means which one makes it, what is the number of x that will make these proportional, right? So you're just going to set up a proportion that has an x in it. So what x do y'all want to use? The x minus 1? That's going to look like it's less complicated, right? So x minus 1 is BC. So that's in the little triangle. So I'm going to keep little, I have the little triangle stuff on top and big triangle stuff on the bottom, right? So you need to keep consistent with that. So x minus 1 is in the big triangle, and it is segment BC. What segment corresponds with BC? EF, which is 18. Y'all with me? Now, if you wanted to make that simpler, you could reduce that 4 over 12 to 1/3. Y'all want to do that? Make it smaller numbers to multiply. Okay. And then cross multiply, so we'll have to distribute there. 3 times x minus 1 equals 1 times 18 is 18. So 3x minus 3 equals 18. Add 3. 3x equals what? 21. Divide by 3. X equals what? 7. Okay, and then we could check it. Okay, because we see our scale factor reduced down to 1/3, right? Right? So if I put x minus 1 right here, 7 minus 1 is what? 6. The 6 over 18 reduced to 1/3. Yeah, and we can plug it in right here. 7 plus 1 is 8. 3 times 8 is 24. Does 8 over 24 reduce to 1/3? Yeah, so that's one good way you can check it, is to make sure everything reduces down to the same fraction. So to find the value of x, all you had to do was set up a proportion and solve for x. Does that make sense? Good job.
All right, so today's notes are going to go a little bit.
So lots of proportions today. Y'all do this as you try. This is honors. Y'all, you try this one. Just like the last one.
So we want 4 methods to solve a quadratic so far. We've got factoring, square roots, and The square root is best used when there's no bx term. So it has to be of the form ax squared plus b. Completing the square is best used when a equals 1 and b is even. Now what are the even numbers? 3, 4, 6, 8, so on and so forth. Yes? So that's going to be a way in order to identify best using completing the square. And then we use quadratic formula for all other cases. All other cases will be quadratic. All right, so let's look at the next part. Now, one thing we've got to figure out is when is a quadratic factor. So an easy way to identify when a quadratic is factorable is with the discriminant. Right? So tell me what the formula for discriminant is.
Check it with somebody, please.
So something is factorable when its discriminant is a perfect square. So how we figure out something is a perfect square, we take the square root of that number, and if we get a whole number, then it's a perfect square, yeah? Let's say we use our calculator. If we use our calculator, we get decimal number, it's not a perfect square. So quadratic is factorable when its discriminant is a perfect square.
All right, what corresponding sides did y'all put together?
So with these next examples, the main
Did y'all do 20 over 30? Did y'all start with 20 over 30? And you can go ahead and reduce that to 2/3, right? So there's our scale factor, 2/3. Equals, did y'all use x plus 6 and 21? Did y'all use that? Now you could have used that 3 times x minus 2.
So we're not going to be using factoring every time. We're not going to use
Okay. So x plus 6 over 21. Y'all okay with my setup? Now if you wanted to use 20 over 30 right there, you could have. All right, so cross multiply. 3 times x plus 6 is 3 parentheses x plus 6 equals, what's 2 times 21? 42. Then you distribute 3x plus 18 equals 42. Subtract 18. What's 42 minus 18? Is what? Good. And then divide by 3 and x equals 8. Raise your hand if you got x equals 8. And I'm quickly going to check it a few spots to see if it makes 2/3. 8 plus 6 is 14. 14 over 21 is 2/3, right? 8 minus 2 is 6. 3 times 6 is 18. 12 over 18 is 2/3 as well. Good job. So that's just a little quick way y'all can check. So any questions about those? So that was side, side, side. All right. So you just have to use all 3 sides are proportional for side, side, side. All right, the last one is side angle side similarity postulate. It's the theorem. Side angle side similarity theorem. I cannot talk today. Side angle side similarity theorem. There you go. So y'all copy this one down. This is our last one.
decide between square root, completing the square and quadratic formula, but we know we are not using factors. Does that make sense? So the next is square root method. So if we go back and look at that table, square root is best used when there's no bx term. Is there a bx term here? Yes, there is. So we're not using square root method. Does that make sense? So now we're down to completing the square and quadratic formula. So completing the square, a needs to be 1 and b needs to be an even number. Is that the case here? Yes, a is 1 and b is an even number. So we are going to use completing the square. Now, you can go back and use the original problem, or we've already got it in standard form. You can start with standard form. Does that make sense? Okay. So let's use the standard form method. So if we're using completing the square, the first thing we need to do is get the constant on one side and the variable terms on the other. So we're going to add 66 to both sides. And we get x squared minus 6x.
So side angle side looks a lot like side angle side did for triangle congruence. The only difference is our sides are not going to be congruent. They're going to be proportional. Okay? But the angle is still going to be between the two sides that are proportional to each other. Okay? So the angle has to be sandwiched in between the two sides that are proportional to each other. Okay? But the sides are going to be proportional. Angles are going to be congruent. Okay? When they were congruent triangles, the sides were congruent. But now we're in similarity, so the sides will be proportional. So it says if an angle of one triangle is congruent to an angle of a second triangle, and the length of the sides, including the angles, remember including means in between, are proportional, then the triangles are similar. So the question is for this problem, are these triangles similar? So these triangles will be similar if the angles are congruent and the sides that include the angle are proportional. Now, proportional means they are the same ratio, right? They reduce down to the same fraction. Okay, so first of all, quick check, are the angles congruent? Yeah, I got a 53-degree angle over here and a 53-degree angle over here, right? So all we have to do is check the sides to see if they are proportional. That means, what side corresponds to the 6-foot side? The 9-foot side, right? And if you don't know, the smallest one will go with the smallest one, the larger one will go with the larger one. Does that make sense? The smallest side of this triangle goes with the small side of this triangle, right? Okay. So 6/9 reduces to what? 2/3. And then the longest side in the second one is what? I mean, on the first one, sorry, is 10/15. And what does that reduce to? So they equal down to the same ratio. So the sides are proportional, the angles are congruent. So are they similar? Yes, because of side angle side. Okay, does that make sense? So you just have to check two sides to see if they are the same ratio, if they equal down to the same reduced fraction. And if the angles between them are congruent, then you can say, yes, they're similar by side angle side. That makes sense? So you got to check proportions. You got to check to make sure they're equal ratios.
Square is what we just used. Yes? Okay. But you just have to look at each situation and go through that thought process of that class.
All right. I'll go with that one. Is that okay with everybody? Yes or no? Okay. Okay, so here's a picture. Y'all draw it. Let's see how much we got. Oh, we just got 2 examples. So, 2 more examples. So here's one. It says, which method would you use to show that these triangles are similar? And we kind of got the bow tie effect going on, right? 2 lines crossing each other.
36 times 4, let's see, 4 times 6 is 24, 4 times 3 is 12, plus 2 is 14.
And they gave us only 2 side measures. Do they see that? Do we know anything else about this figure though? We got a pair of vertical angles in there, right? So we know that the 2 angles right here are congruent, right? So I've got 2 sides, so I think I can use side angle side. Y'all agree? I have 2 sides and the angles between them, so I think I can use side angle side. Does that make sense? So I'm going to go ahead and see if they're similar to each other. We already know that angle C and angle C are congruent, right? So I got the left triangle and the right triangle. Okay? What's the short side over here? 9, and it's going to correspond with the short side over here, which is what? 15. So I'm going to do 9 over 15. And then for the other one, the larger side in triangle ABC is what? 18, and the larger side in triangle CED is what? 30. And let's see if they reduce to the same thing. Well, I can divide the top ones both by 3, and that is 3 over 5. And, yep, divide by 6 and get what? 3 over 5 again. So are those similar? Yes. They're similar. But you have to check proportionality of the sides to make sure they're similar, right? We already knew the angles were congruent. So all I had to do was test the sides, the corresponding sides, to make sure they reduce down to the same ratio. Is that cool? So it's pretty easy. Pretty easy. Now, number 5, I don't know what this little thing is right here. I can't hit it all. It's a P. I don't know why I have a P there, but anyway. So, what method, which one of these 3 methods right here do you think we would use to try to prove that these are similar? Side, side, side. Because all I have is 3 side mixed. I don't have anything with angles that says angles are congruent, so I can't use either of the other 2, right? So let's check to see if it is. And I like to do short, short, middle, middle, longest, longest. That's just easiest to me. So what's the shortest side in the first triangle? 16 over what's the shortest on the second triangle? 12. What does that reduce to? 4 over 3. Okay. What's the middle side in the first triangle? 20 over what's the middle side in the second triangle? 15. Does that reduce to 4 over 3 as well? Yep. Divide them both by 5. And then the longest side in the first triangle is over what's the longest side in the second triangle? 24. I can divide those both by 8, right? Do I get 4 over 3? Yes. So yes, they are similar. Okay. So on your quiz tomorrow, make sure that you just don't see 3 sides with 3 sides and then you say, yep, similar side, side, side. You actually have to check the ratios. Okay? Match up the corresponding sides and make sure they equal down to the same fraction. Okay? So any questions about any of this? All right, that's the end of notes today. Da, 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 da. I like these short lessons, don't you?